Hello class. So today I'm going to help you study for your first quiz, and the quiz is going to be on questions 6 to 9 of this pulleys and ramps pre-lab assignment. So if you can answer those questions, then you'll be prepared for the quiz, and you're allowed to use your notes for the quiz. And the quiz is going to be on paper. Okay, so let's get started. So let's look at question 6. So question 6 says, a car travels at a speed of 50 miles per hour for 3.25 hours. How far did the car travel? So let's start by underlining all the important information, all the numbers, all the measurements in the question. So the question says that the car travels at a speed of 50 miles per hour for 3.25 hours. And the question is asking, how far did the car travel? So we need to choose which variables are going with these different numbers, these different measurements that we have in the question. So a speed of 50 miles per hour, what variable goes with a speed of 50? What variable goes with 50? So S equals 50. For 3.25 hours, what letter goes with 3.25? That is going to be time. Time is T. So T equals 3.25. And how far did the car travel? So that is talking about distance. Distance is D. So D equals D, because the question is asking about the distance. We write D equals D, and we put a question mark to remind us that that is what we are looking for. Okay, so let's solve this problem. Which equation should we use? This equation or this equation? Which equation includes speed, distance, and time? It's the left equation. So let's use that equation. So first let's just rewrite the equation. S equals D divided by T. Now we put the numbers from the question into the equation. So what is S? S is 50. What is D? D is D. What is T? T is 3.25. Okay, so what do we need to do to both sides of this equation to get D all by itself? We want to get D all by itself. So what do we need to do to both sides of the equation? How do we get D all by itself on both sides, on this side of the equation? So right now D is being divided by 3.25. So we need to multiply both sides by 3.25 to cancel out that division. And so when we do that, we get that D equals 50 times 3.25. And so we can do that in our calculator. 50 times 3.25 is 162.5. And what is the unit that goes with distance. So the unit that goes with distance is meters. That is m. The unit that goes with speed, that is meters per second. That is meters per second. And the unit that goes with time is seconds. That is s. So 162.5 meters. All right, let's look at question 7. Question 7 says, a car goes from an initial velocity of 20 to a final velocity of 100 miles per hour in 4 seconds. What is the acceleration of the car? So let's just erase some of this stuff so we can see the equations a little bit better. So what variable goes with initial velocity? Looking up here at these equations, what letter goes with initial velocity? So initial velocity is vi. So we can write here, we can write vi equals 20. What letter goes with final velocity? So final velocity is vf. So we can write vf equals 100. And what letter goes with, what is this asking about? 4 seconds. What information is that giving us? What measurement is that giving us? So seconds, that is giving us time. Seconds gives us time. And the letter for time is t. So we can write t equals 4. What is the acceleration of the car? So what letter goes with acceleration? So acceleration, that is a. So we can write a equals a, because the question is asking what is the acceleration. So let's just erase some of that stuff so we can see the equation better. And let's rewrite, which equation should we use to solve this problem? Which formula should we use to solve this problem? Let's use this equation because it includes all of these variables that we have in our problem. So let's write down the equation. A equals VF minus VI over T. Now let's put information from our question into the equation. So for A, we put A. For VF, we put what? What should we put for VF? For VF, we put 100. For VI, what should we put for VI? For VI, we will put 20. And for T, what should we put for T? For T, we will put 4. So, where should we put? We can solve this equation in our calculator. And to do this in our calculator, we just need to put parentheses. Where should we put parentheses in this equation to solve it in our calculator? Well, remember, we only have 2 rules we always need to remember. We always put parentheses in our fractions, in the top and the bottom, and we always put parentheses in our square roots. So we need to put parentheses here. In our calculator, we can find a by just typing in parentheses 100 minus 20 parentheses divided by 4. And when we type that into our calculator, we will get that a equals 20. What unit goes with acceleration? So the unit for acceleration, the unit for that is meters per second squared. So we will write 20 meters per second squared. All right. So let's move on to question 8. Question 8 says, in graph A, what is the speed of runner 1 from 0 to 4 seconds? So in graph A, here is runner 1 at the top, and here's runner 2 at the bottom. So we get the speed of a runner by finding their change in distance divided by the time. So the runner 1 is going from that point to this point. So what is the final distance of the runner? What is d2? What is the final distance of the runner? So if we follow along here, we will see that the final distance of the runner is 20. What is the initial distance of the runner? So looking at the graph, the initial distance of the runner is 10. So in our equation, we can write speed equals 20 minus 10. And we just need to get the time. So what is the amount of time that the runner took? Well, if we look at the graph, we can see that the amount of time is 4. So in our equation, we can write divided by 4. Where should we put parentheses in this equation to solve this equation? We need to put parentheses here. So in our calculator, we will write, to find speed, we will write in our calculator, parentheses, 20 minus 10, close parentheses, divided by 4. And when we do that in our calculator, we will get that the speed equals 2.5 meters per second. All right, so finally let's answer question 9. So question 9 says, what is the speed of runner 2 in graph B from 0 to 4 seconds? So runner 2, that's this runner down here is runner 2. So runner 2 went from this point here to this point here. So their speed is their final distance minus their initial distance, their change in distance divided by the time. So their speed is, what's their final distance of runner 2 in graph B? Well, here's their final point right here, and their distance at that point is 20. So their final distance is 20. What is their initial distance? Their starting distance, D1, that is here, this point. So their initial distance here is at this point right here. And so that distance is 10. Divided by, what is the amount of time that it took for them to run that distance? So here, the time is 4 seconds. So we can write divided by 4. So in our calculator, we would, where would we put parentheses in this equation? So we would put parentheses here because it's at the in a fraction. So in our calculator, we would type parentheses 20 minus 10 parentheses divided by 4, and that gives us 2.5 meters per second.